gases and solutions, we start to look at the learning goals. We have three separate sections. I'd like to make it further, and then of course oxygen through the first two. Although the second one I have to come back to and finish up Thursday, giving there are section 2 and 3 for Thursday as well. In that dabbling in the second, but really and I would add together 2 aluminums, 3 sulfurs, and say it's a shorter content unit with just 3 sections from the chapter. That's a manageable amount. That process. But because it's heavy in mass, it just takes the repetition to become proficient. 12 oxygens, and we found there's some. So we want to work on both. But you would add. We'll introduce the chapter by looking at something called formula mass. I call it molar mass, and the chemical unit called the mole. The central calculation of all of chemistry is the mole unit. Once we get a handle on traveling the mole map, using different ways that we measure matter, molar by weighing it very skilled, volume, or by counting particles, traveling on the different roads on the mole map allows us to move to the next section where we determine empirical and molecular formulas. Let's put this one on the attendance sheet. There's 2 of them here. If I know a compound's mass percent, the elements and their contribution to the weight, and let use that information to determine its chemical formula. On the attendance paper, turn number 1 is called molarity, which is the concentration of a solution. The first I'm letting you know that out of the mass 3 grams, when you go to read your chapter, there are other concentration units discussed, such as parts per million, the unit that we are given mass. I'm taking that off the table and just focusing on the molarity in that particular section. So if you're using those Google Slide decks to prepare for each section, you'll see that note made when you get to that. It says focus on molarity, but let the end of that section go. The unit mole, so out of those 3 things, we're going to begin by exploring the mole map. This visual that I gave you as a test-taking tool page, like if you're like me in the visual, it helps me figure out how many steps are involved for each and every calculation I'm asked to make. Are measured on a scale. A test-taking tool page. So we're heading from the center. You need a periodic table. And if I may, look at the beautiful notes that are on this periodic table that we made together. That literally you trip over the conversion factor to bring you from one unit to the next. And I see that the charges are placed in each column. If I'm standing in the center and want to head out to the scale to highlight where the metals and non-metals are, you might have even labeled where the alkaliners, all of those families. So that periodic table lesson, that's a test-taking tool page in a mole. Unless you want to memorize them, I would highly recommend that polyatomic ion chart. I gave you a couple of varieties to print out. One of them looks like a long list. The other is in this kind of a conversion factor area. And of course, I want to set up this conversion factor that cancels the moles, and that's the other tool for this particular section. To the gram. With those tools and the calculator, we're about to engage in the practices of measuring matter. So relating it to that central calculation of the potassium way. What do we remember about the chemical mole from being alive so far in our journey called life? In a different chemistry class, if you've had a background, my mole unit cancels hearing the word mole. And I'm left with the unit called engage in a conversation with people nearby so I can eavesdrop mole, so I can hear a little bit of math prior to come out to a gram. Not a question that's right or wrong. What do you remember? Have you ever heard? What brings to your mind when you hear the chemical mole? Down here to counting or down to the scale. When you head out from the center, you multiply. And we'll soon see one where we go in means to divide. What's 3.32? Anything at all? Times 39.1. Okay. Carrying that 1 decimal, and you'll get 129.8 grams of potassium. We use the molar mass to exchange from the unit mole. What's interesting, and I only made it down the center aisle, but I remember hearing, okay, I printed it, and that's as much as I know. That's a good start. Or some people said, well, I remember hearing it maybe from high school, but it's been a while. We're assuming we're still being asked to solve for grams, so I still want to know a mass. That we have no prior knowledge, so it's all brand new. Mole. We're going to introduce the chemical concept of mole as the central calculation of all of chemistry and how we relate it to measuring matter. When we measure matter, we do so one of 3 conversion factor we can count that will cancel the word mole and bring me to the gram. All of the ways that we measure matter by counting, by weighing, or taking a volume lead back to the central calculation, we were just practicing called the mole. So to travel the mole map, standard international unit, MOL, if you remember on your SI chart. I don't need to show that work on a piece of paper. I just do that on my calculator. International unit that measures the amount of stuff. That's literally its definition. There's 6 of them there. I'll add that to hydrogen. So when we kind of think about the mole concept, and on the oxygen, it's a way of counting by weighing. It's a way of knowing a volume by 12 H's and 6 O's. It allows me to exchange from one measurement to another, what we refer to as molar mass. Which is an important thing in chemistry. And the molar mass is what exchanges if I think about it, where chemistry actually occurs is at an individual molecular level. I want to say and yet it's the most impossible thing to do in a lab is to count out taking 180 grams, 1 atom of carbon, 2 atoms of carbon. We can't do that, and yet that's where the chemical reactions take place. 4.52 but if I can weigh out the carbon, walk to the scale and weigh out 12 grams of carbon, so you got a big lump of black powder on your scale that's carbon. I now know by knowing its mass how many atoms are sitting on there. The mole is that unit that allows us to exchange between measurements. Chemistry is a very quantitative science. Chemistry can be a very qualitative science. Let's make sure we understand the difference. Oh, I have a screen error. If it's quantitative, which this chapter is quantitative. So I'm probably off a little bit, aren't I? It's all about numbers, isn't it? Quantities, number crunching, me and my calculator becoming new best friends. A quantitative lab. Let that go. Well, you had one, your very first lab. Wasn't that a very calculator-heavy lab where measurements mattered? Your density lab. You had to take great care in getting a precise mass and a precise volume, and those measurements mattered. That was a very quantitative lab. No one's yelling, so it must be agreeable. This week, it's more qualitative. I swear, when you try to talk, write, and calculate, something falls apart. Right? Observation-based. Describe the texture. Describe the color. Describe an odor. All of those things that are easily observable about a sample of matter. You want qualitative analysis helps me figure out the identities of unknowns, for example. Is this sample behaving the same way as the known? Number 3 is what we'll focus on. Example. Let's calculate the number of moles. We're making sure that we're getting a handle that is a unit called number crunching. Me and my calculator. And this time I'm given the chemical concept of the mole. The mole is the central unit that allows me to exchange between the ways that we measure matter. On the mole map where I'm starting and where I'd like to travel to. That's the purpose of a visual. So when we think about answers given to us gets me from place to numbers, quantitative. Where I'm starting at, if we think about answers that are not in the beginning of my journey, but rather a description, and I want to go into the mole unit. Qualitative so my journey has me starting at the scale with a one-step conversion into the mole. Convert the mole map allows us to measure matter and you'll literally trip over the conversion factor on this visual. When we measure matter, this time the conversion says put the mole unit on top, we can count the molar mass unit on the bottom, and we can take a volume to head in. And on this slide, I simply showed set up the work for number 3. Walk down the grocery store aisle, and you'll see 3 ways that we can purchase of nitrogen gas. You can count out individual particles. When I read like nitrogen gas, eggs, or I have to remember that horses I buy 4 apples, anything more brown eyes, so they go to waste. What is 4? That's formula. That's my elemental form of nitrogen. I can get 4. That's counting out. Weighing, you spend time in the bulk that I would food be incorrect if I weigh out a certain amount of 14 for the molar mass. Milk bones, for instance. I have to use 28. You buy a pound of hamburger. You're weighing out a certain amount of product, and I want to end with the mole. Or you can buy something that's taking a volume, a gallon of milk, a bottle of pop, whatever it might be. 2 ends added together is a certain 28 grams. In chemistry, most likely volumes are for gases. So I divide to head into the liquids. You can calculate a volume by water displacement for a solid. And I get 2.68. Notice that, like counting by weighing, by taking a volume, the ways that we measure matter, the mole is a unit that allows me to exchange from one into the other. Of nitrogen gas. So if I walk to the scale and weigh something, I know how many atoms are sitting on there. I know how big the balloon would be if I were occupying a volume of a gaseous product. My fourth example, I tried to integrate, is to measure matter, a little metric and be able to exchange a little bit of review there. It says, let's calculate the moles given 0.25 kilograms of sodium oxide. If I say the word pair, I have a pair of mittens. I have to first of all remember how to change a kilogram to a gram. Represents the molar mass is in a gram unit. And if I have a dozen, I've got to do a little switch of the decimal there. Kilo has to become gram. Represents a number. And I have some nomenclature still there. I have to read the word sodium oxide and be able to write a formula to know what the copy machine regularly like I do. A ream of paper is 500 sheets. How many moles given a gram? I'm starting at the mass, the scale, and the number is the same thing as a chemical mole. The mole represents a number, and it's a very, very, converted to a gram number because atoms are so small. The kilo is the prefix. It represents 1,000. It's a number. So it takes 1,000 and it's grams Avogadro's number. A kilogram. And that is definitely a real picture of Amadeus Avogadro. The little metric staircase is what I recommended. It's a little scary. I'm just watching your face. You want to memorize all the prefixes, more power to you, but I did say that would be an allowable test-taking tool. 6.02 times 10 to the 23rd is called Avogadro's mnemonic device. He did not count it. He did not determine it. It was an honorary naming. So whatever works for you, but have that crutch there. Avogadro's number is 6.023 times 10 to the 23rd power. So 250 grams when you multiply that out. After that number. Do you see how significantly large that number is? Perfect. If you were to take a grain of sand, how tiny is a grain of sand, grams of sodium and have a mole's worth of sodium is a plus 1, not just one, but a whole mole, 6.02. So my formula is Na2O, sodium of sand. I have to remember to check charges, crisscross, and write a correct formula for sodium oxide. My conversion factor will cancel the gram and bring me to the mole. Would it fill the city of Long Beach at this point? Sodium has a molar mass of 23, but there's 1 meter high. Oxygen has a molar mass of 16. Take a guess. 46. How big is a mole? 16 is 52 grams. Would it fill? I can't fill the world because that would be too much. What do you think? How big is big? Carrier 1, the story that you'll read about is in your text. If you had 1 mole of sand, it would cover the entire state of California, which is, but I can do it with a rather large state. 250 divided by 62, and do you find a mole of sand something? That's a big number, isn't it? And that unit ends up to be small is an atom compared to a grain of sand? Take a break with your pencil and calculator, converse with your neighbor. Because what does a mole of atoms look like? How do I know whether to go into the mole or out of the mole? How do I know which direction I'm supposed to be traveling? Talk about that for a moment with the neighbor nearby. Let's say you had a mole of zinc. Because didn't you use zinc last week in your lab for the displacement? If you had a whole mole of zinc, how much would that look like? Would it fill the room? Would it fill the building? Or would it fill a little weighing tray? A little weighing tray. That's right. I'll tell you, a whole mole of zinc would occupy exactly 65.38 grams on the scale. That's a mole of zinc. If I wanted a mole of carbon on the scale, I would weigh out 12.011 grams of carbon. That would be a whole mole of carbon. All right, well, let's try traveling a new road, shall we? We're all warmed up on the sand to the mole. This allows us to turn grams into moles. It's a massively large number. I'd like to next explore a second way we measure matter, and that's by counting that number, individual particles, 10 to the 23rd. What's visual is supposed to be looking like individual atoms all kind of stacked together. That happens to be the number of atoms it takes called representative particles. For any atom, particles is kind of a general term. Atomic mass in chemistry, the particles will either be atoms. If I wanted to weigh out one whole mole of the sulfur
and yes,
atom.
I abbreviate formula unit as the ever-popular F1, 2 atoms,
and in
3 atoms.
chemistry,
That's a nice thing to say. Oh,
but
a formula
you can weigh
unit?
out
okay, FU2,
32.06 grams
atoms,
of sulfur,
molecules, and
now
formula
know
units.
with confidence
that means
exactly
individual
one
elements,
mole of sulfur,
molecular compounds,
6.02
or
times
ionic
10 to the
compounds,
23rd
sometimes
atoms
of
sulfur. I can count
that's what those
by
little
weighing
jelly beans
and how much I weigh.
That's what they look like.
It's
Those
found
are
on
the
the periodic
individual
table.
pieces.
That
So now the
number,
word clue says
Avogadro's
how many
number,
atoms are in this many moles
how many atoms
of
it
carbon
takes to achieve
so visually,
the molecular
I'm
weight
given
on
the unit
table.
mole, so it's
given
a
the unit
derived
mole,
number.
But I
not
now
been
want
counted.
to travel a different direction.
It's been
I want to go down and
derived based
count
on the weight
individual
of the
atoms
in that mole.
But
that means I'm
some
heading this
vocabulary,
direction
gram
on the mole
atomic
mass,
from
gram
the
molecular
center
mass,
down to
gram
the
formula
individual
mass.
pieces. It just
And when I'm
depends
at
upon
the
what it
center and
is
I
that
head
you're
out,
weighing.
I literally trip over
if
my
I go
conversion.
to the scale and I
I've
weigh
learned
out
that there's
atoms,
an Avogadro's number.
Atoms are the building
of
blocks
atoms
of elements
in a mole.
If I went and weighed out
Avogadro's number
carbon,
is
think of like a lump of
6.023
coal
times 10 to
as
the
carbon,
23rd.
the black soot carbon.
I often just write 6.02
I would be weighing atoms
and get close
of
enough
carbon.
to the answer.
That's its building
most
block.
often don't carry
the gram
the 6.023
atomic mass
simply because
is
the number in the problem rarely gives me that
grams,
many
the mass
decimals.
of one mole.
So the work
if I'm
would look
weighing
like
atoms,
gram atomic
6.79 moles of carbon. Sometimes I'm weighing
I'm going to set up a conversion factor
not just
where
elements,
the mole
but
unit
compounds.
cancels,
And we know
and
compounds come in two different
individual
flavors.
atoms.
They can be
of
molecular,
carbon, or they can be ionic.
By definition, you can see on your
we know that molecular
one
compounds
mole
are built
is
of
equivalent to
molecules.
saying 6.02
If I wanted to
times
know
10 to the 23rd,
how much would I
atoms
weigh
of
out to get a
carbon.
whole mole of water molecules?
Please
do
do
not
not
wait
wait
until
until
test day to figure out how to
all
enter
of them are
scientific
non-metals,
notation
so
into
it's a
your molecular
calculator.
compound. Water
Most
exists in
often,
nature
if
as a
you wait for
molecule,
test day,
so it has a
you'll be
gram
off.
molecular compound.
And every
How much
calculator
would
is
you
just
weigh
a little
out?
bit different.
Some have,
Well, the secret still
times
lies on the
10 to the
periodic
button.
table.
like
I have
a
two
raised
H's
like here,
and an O.
Some
How
have an
much
E
would you need to weigh
key.
out?
That's what mine has. Some
Well,
have
each
an
hydrogen would
ESP
contribute
key, depending upon the brand
1.008
name.
grams.
There's
Can you
two of
take a
them.
moment with your
And an
calculator
oxygen
and just put
essentially
your
is
finger on the button that you
15.999. I call
believe
it
to be
15.
scientific notation?
I'd weigh out
18 grams of water to get one mole of water.
If you take a moment and find it.
Gram molecular
If you have
mass.
a Texas
Molecules.
instrument, you most likely have an
Sometimes we have to weigh out
key.
salts.
Ionic
If you have a
compound.
Casio, you
Their
most likely
building
have a
blocks are
times
known
10
as
raised to
formula
something.
units.
Or
We
sometimes
commonly
I
call
see
them
it as
EXP
salts.
on a Casio.
Metal to the non-metal.
I'm not too familiar with
charges.
Casios.
You're making
I've just
ionic
owned
compounds.
Texas Instrument,
If
not
you
because
go
there's
to
a
the
special or anything,
scale
it's just
and
what
weigh
I've
out
had.
salt,
Let's call it sodium chloride is one example.
if you
How
don't
much
find
would
it,
you weigh
ask
out
your neighbor
to
to
get
look
a
on your
whole
calculator
mole
and see if
of
they can
sodium
help you.
chloride formula units? Again, the secret's on the periodic
yes,
table.
it will be.
Sodium, with its
Let's
mass of
solve it and see if we can't.
22.989,
let's make
call it
sure we get a
23.
common answer.
Chlorine
My
with a mass
key
of
sequence,
35.45
mine on my
calculator. I have a
add those
Texas
together,
instrument to
my
find the
key
mass of
sequence
a whole
would
mole
look
of
like
sodium
this.
chloride.
It would be
With sodium's
6.79
mass
times 6.02,
and chlorine's mass.
and then I have to press second
I
function.
add those together. That's the blue button
and now
on
I know
mine.
how much
And then
to
I
weigh
hit on
out
top
to
of
get
the
one
comma.
whole
mole of
I
sodium
have an
chloride.
EE key.
Why are
That's
there
on top
three
of the
different
comma.
words, three different vocabulary words? Just simply because we
And then I
weigh
hit
different things in
23
chemistry.
equal.
We can weigh atoms,
That's my
molecules, or
key
formula
sequence.
units.
It may or may
It's
not
a very
match yours if you have a
specific
different
term
brand.
based
So
on
let's
what
hit
it is
that
you're
and see if we
reacting,
get a common
you're weighing
answer.
out. 6.79
I
times
tend to use this
6.02,
word called
second
molar
function,
mass.
EE,
It's like the big
23.
umbrella to mean
My
anything.
screen reads,
If I don't want to be
6.1,
specific
and
to
I'll
let
just
you know
round
if it's
2
an atom, a
times 10 to the
molecule, a formula
24th
unit, I can just
atoms
call
of
it the
carbon.
molar mass,
and now I've accomplished all three of them. So one word to define anything you weigh out, one whole mole of anything.
Oh, I hit a 9
which is
and
called
not a
its
6.
molar
Dang it.
mass, the mole of any substance. That's the term that lies
Just checking.
on the mole map. Is
I
the
know you're
term
really hitting 'cause
molar
you're finding
mass.
my
How
calculator
much do
boo-boos.
you weigh out to get a whole mole of substances?
What if I said it really was equal
Let me
to
pause and ask
4.1
for some
times 10 to
conversation
the
with a neighbor
24th?
related to this picture. What do you see in the picture? What do they represent? Now I have more confidence because people said,
that's what I got, instead of, what did she do? That makes me feel better. Oh, you're checking sig fig? So that particular question, these are little pieces of filter paper, right?
Let me scroll up and look
they're
at
about
sig
this big piece of filter paper.
3 sig figs given.
And you see a mass
so my
written under each one.
3, so 4.09 would be a better answer.
Beautiful. The periodic table. The element named zinc.
Maybe you
the element zinc has the symbol Zn. It's the element you used last week in the lab when you determined its density. It has an atomic mass of 65.38.
To make sure that, come test it, you have a common answer with you, so that the
on that piece of filter paper
might be different depending on your own calculator. Just make sure that you're coming up with the same answer.
1 mole of zinc. That is exactly 6.02 times 10 to the 23rd atoms of zinc.
Anybody in that
I didn't count it. I weighed it.
Casio.
But I know how many atoms there are
because I can relate that to the
mole. There's your 12 grams of carbon, 24.3 grams of magnesium. So let's try one more, and I'm going to say I want to turn in today. Let's try this, and then we'll try lead, silicon, and sulfur. Why don't they all have the same mass? If they're all the same number of particles. How many formula units are present in 9.39 moles of sodium chloride?
Tell your neighbor.
In 9.39 moles of sodium chloride. So remember, the building block of an ionic compound is called a formula unit. A building block of elements are called atoms. A building block of molecules, a building block of salts. So don't let the
vocabulary
word
kind of throw you. I'm
not
calculating formula
units. It's like
units.
asking would
it's just
a vocabulary ping pong balls weigh the same as a mole of an ionic compound.
That's the number of them,
just
but
as elements
would have
atoms
or
molecules.
Not, they have different masses.
You want to make sure
atoms
come in different sizes.
So it's still just a one-step
bowling
process,
ball and
even though the
ping pong ball have
different
sizes.
It's just because I'm counting
the secret of finding
those individual
lies on the periodic table. I still know that on a piece of paper to turn in today
would contain an Avogadro's number of particles.
Tell me the gram atomic mass of carbon, of hydrogen, and of sulfur.
The formula
when
unit
I define the term gram atomic mass, I'm telling you that I want to know how many grams to get exactly 6.023 times 10 to the 23rd atoms of each of those elements. Tell me the gram atomic
we want to know the number of particles.
Sometimes
I
multiply to head out.
We're going to multiply our mole number of 9.39.
How much would you weigh out to get a whole mole of each of those elements? I wrote mine, and I wouldn't mind if somebody just nodded, say, yeah, I got that, before I quickly erase and re-hit, right? So we've traveled from moles to the scale. We've traveled from moles to the particle. We're just using different exchange units because we're heading in different places. There is a north on our mole map. It's to the world of volume, where we learn that 1 mole of any gas is 22.4 liters big.
Let's agree
to
carry
out
one
later in the lesson
from the periodic table.
We're wondering how many decimals does she want me to grab.
The 2 main rows presented in our
chapter,
a little
from
bit
the
different.
scale
Some
to
have
the
many
mole,
decimals, some have
from
1
the mole
or 2.
to the individual particle.
To carry 1 decimal.
It's not until we get to the gas laws later in our journey that we'll head north to the land of the balloon. So, for instance, when you found carbon on the periodic table in the box,
focus on those 2
as you perfect mastery. If we carry just 1 decimal, I would weigh out from your homework
grams
that
you might want to
carbon.
You'll see
to have exactly 1 mole of carbon
which is the same as saying 6.02 times 10 to the 23rd atoms of carbon.
I said let's be cautious of what we call a vocabulary
on the periodic table. 12.011
what I'm referring to
was the
is,
number I found for the mass
reading
number,
it through,
and that's what I'm carrying one decimal.
Is a vocabulary
the element
mismatch.
hydrogen
How
on the
many
periodic
sulfur
table
atoms
are present in 5
It's the
moles
very first
of
one. It says
aluminum
1.008.
sulfate. Yours might be different.
I'm asked
if
to count
it just rounds a little
individual
different or has a
atoms of
different number
sulfur,
of decimals.
but I'm given
I'm going
something
to call
much
that 1.0
larger
grams of
compound.
hydrogen.
When
Atoms
I
of
see
hydrogen
that, I
would
know
weigh
that it's
1
going to
gram.
kind
of a trigger for me, a word
and
clue
sulfur,
that it's going to be a
when you see that on the
two-step
periodic table,
conversion
sulfur
factor,
has an element
vocabulary
F. It says
mismatch.
32.06.
So I'm going to
Rounding
begin by
correctly,
writing
we
down
should carry
the
that
unit,
as
which is 5.1 grams. So that's what I'm asking.
And then it
let's
gives
carry
me the
one
name
decimal, so we have
aluminum
a common
sulfate.
theme as we
We've written that a
proceed
few
in our
times.
work.
They have
So
aluminum,
we've just written what's called
which
a
I know
gram
carries
atomic
a
mass for
+3.
each of these elements.
Sulfate
is a polyatomic.
Keep that word
carries
going
a
on your
-2.
paper.
So when I write
Do the
aluminum
following for
sulfate,
the
we get
molecules
Al2
of sulfur
parentheses,
trioxide,
SO4,
a molecule of
taken 3
hydrogen,
times, and a molecule of carbon
my
dioxide
formula
of aluminum
I remember
sulfate.
learning for nomenclature, non-metal
My
took the
first
non-metal
conversion factor
we used
needs to
prefixes in
cancel
their
the
name
mole
and bring me to the
monoditritetracounting
individual
with the
particles
subscripts of this compound.
So when I hear subscripts, is this
I hear
compound
those
an element?
prefixes,
I know it's
Is
molecular
it a
compound.
molecule or is it a formula unit? What type of particle is this?
The gram
salt?
molecular mass.
Perfect. It's a formula unit. Even if you wrote the word particle, and that's fine, you realize that it's a compound and not the individual sulfur atoms. I know that there's 6.02 times 10 to the 23rd formula units of my compound, aluminum sulfate,
If
in
I
every
can't
1 mole.
write a formula,
That's your first conversion
I can't
factor.
get the molar mass.
And I therefore
I have
won't
the
be
moles
able to
canceled,
calculate a mole.
and I'm at the
That's a
compound
fundamental
aluminum sulfate.
skill that carries
But
from
what
the
does the
entire
question
course.
ask me?
Being able to write a
It asks
correct
me to go
formula
a little bit deeper,
so
doesn't
that
it?
your
I'm
math
not
comes out
asking about
correct.
compounds. I'm asking about
from you.
individual sulfur atoms.
With a lot of tool pages to
In every one formula unit, how many atoms of sulfur do you see?
No, I'm asking for grams, not how many atoms.
I see 3
There's
as
going
well.
to be
The parentheses
that many
taken
molecules
3
at
times.
the end. Avogadro's
That 3
number.
is talking
But
to
I
the
just want a
sulfur.
gram unit.
There's 3
gram
sulfur molecular
atoms,
mass.
how much would
in
I
every one of
weigh
those
out
compound
to get a
formulas.
mole?
So what I'm referring to
Absolutely,
is a
that's what we did.
vocab
Perfect.
mismatch. I just
So
mean
for
that if
instance,
I'm asked to
sulfur
count something
is the element
smaller
S
than the substance they gave me,
trioxide.
you should be suspicious that it's
How
a
does that
two-step
feel?
conversion.
Hearing the word
I've got to
sulfur
count
trioxide,
something
are you able to
inside
go, oh,
smaller
that's SO3
than the compound
if
they
not,
gave me.
please keep practicing.
So I'm going to
It's a
take
fundamental
5
skill.
times
And it
Avogadro's
just takes
number
repetition as any new
times
language does,
3.
right? It just you need to speak it to get better at it.
We looked up sulfur a moment ago, and it had a molar mass of 32.1. There's 1 sulfur in that compound. It's contributing 32.1 grams
to the entire compound.
9.03 times
Oxygen,
10 to the 24th.
when I looked it up,
said 15.999. If we carry 1 decimal, it will round to 16.0 and just make them describe to you. Just check in with one another. How did we know there were 2 conversions in that one instead
Each
of
the
1
oxygen weighing
that we've been
16?
practicing so far? So the total contribution from the oxygens is 48 grams. When you add 32.1 and 48, you get what's called, I didn't hit that right, 32.1 plus, I multiplied, you get 80.1 grams of sulfur trioxide. Just adding the individual atoms together gives me the molar mass, the gram molecular mass of that compound. On the previous screen, I asked you for the gram atomic mass of hydrogen. Here I'm asking you for the
Number
gram
9 allows us
molecular
to
mass.
practice kind of
That
that
means
same
hydrogen
skill,
is now
and you'll
a
see this one on
molecule.
your sapling. So let's
There
set this
are
one up as
7
well.
molecules.
Same skill.
That
How many
elements
moles of
the periodic
N
table that
are in
exist as diatomic
0.175
molecules? And I've asked you
grams
to
of
memorize those or somehow
N2O.
print them on your periodic table
There is
somehow.
a clue
We even
there
had a funny
that
sentence.
lets me know that there's
oats
2
for clear
conversions
brown
involved.
eyes. There are other
What does
mnemonic
that
devices
clue
to help you as
look
well.
like? What is,
A
what's
molecule
the
of hydrogen
to
is
let me know 2
H2,
conversions?
therefore its gram molecular mass
is 2 grams.
Beautiful.
2
Absolutely.
H's added together.
What she said was, it's asking about a particular
atom
inside something
has a
bigger,
molecular
right?
formula
bigger
of
molecule.
CO2. Has some N's in it.
Carbon,
and we're going to focus
who has
on
an
that.
atomic
I call
mass
it a vocab
of 12.0.
mismatch. That's my clue that we're going to have
has
two
a molecular
conversions.
mass of 16.
So I'll start, but there's 2 of
with
them
my
there.
So I take a carbon,
0.175 grams
add
of
it
the
to
molecule
2 oxygens,
and get the sum of all 3 atoms
I want to
together.
go into the word
That's
mole,
added to
so
2
I know
O's.
to place 32 and 12. That should be 44
moles over
grams
grams to
of
cancel the
carbon
gram.
dioxide.
Now, visually on your mole map, you're down at the scale and you want to head in. That's the direction we're heading.
It's a molecular
and when
mass,
you head
not
in
an atomic
from the
mass.
scale into the mole,
Here's an atom
you
of
literally
H.
trip over your conversion.
Here's a molecule
it says
of
place
hydrogen.
1 mole
2 atoms
over the
together.
molar
It's a
mass
great
of your
reminder.
compound.
An atom versus a
That's
molecule.
our first conversion.
2 H's
I've
bonded
got to
together
add
to create a single molecule, weighs 2
grams.
An atom
To
of hydrogen
from the
you would not
oxygen,
trip over
and
an
I get a
atom
molar
in nature.
mass of
It's
44.
Got to be hooked to something else.
Right
The
now,
last
I'm at
part,
moles
I'm just really
of the
being sneaky, and it's my way of making you
N2O.
practice nomenclature. Really is the drill here. Keep
Let's
going
look
on your
deeper
paper to turn in. I want
in
to see
every
the
mole
nomenclature.
of your compound.
Tell me the mass
how
of
many
sodium
N's
chloride,
do you see?
ammonium carbonate, and potassium oxide.
2 of them.
I have to see that you can write formulas to build a foundation to do a mole calculation.
Nitrogen.
Since I know these are formula masses, I know these are ionic compounds, I have to consider
I'll divide
charges
to
when I write
head
out
in
their
to
formula.
make that a mole
So your
unit.
tool
And then
pages,
notice
the
that there's
periodic
twice as
table
many atoms
and the
of
polyatomic
nitrogen
ion
per mole
chart.
of
Those are your 2
compound.
crutches here to be able
So
to write correct
when I
formulas.
solve for this,
Write the
0.175,
formulas on your paper to turn in,
I'll
and then
divide by the
sum
molar mass
each
of
atom
44,
to tell me the formula
and then
mass.
multiply by 2 the number of nitrogen atoms. And when I solved, kind of tiny, 0.00795, but I'll look up. I got 2 people to nod so far. Anyone else? Same answer? If I stare at you long enough, that's what I'm doing. Please confirm my math. As I'm presenting, I really love Calculator Buddy, so feel free to yell if I make a mistake. It happens because I'm trying to do too many things at once. And if I'm chewing gum, things really fall apart. Remember for your test day to have a physical copy of your periodic table. It cannot be from your lab book, all right? Make sure you print one. My answer
you have a
to that is
polyatomic ion
if it's
chart
necessary
and
for
that you have the
significant
mole
digits,
map printed.
then
They can't be
sure,
electronic.
it might be, but
They
other than
can't
that,
be
I
from
don't
a
care
book,
because I read them
but
one
they
or the
can
other.
certainly be out
So,
as
for
long as they're
instance,
individual
her question
pages.
was, do I have to place scientific notation? And my answer is no. I read them as the same thing, unless you need it for sig fig reasons. Here's some more sapling, and I wouldn't mind just taking as many few minutes that are left to continue practicing on the homework questions to give you a flavor of how this will come out.
I think what I'm noticing is if you're
This
feeling
is another
stuck,
screenshot,
it isn't the
and
new
I just
part
put it
about
below
math,
that on the
right?
sapling.
It's
If
the
you have your
formula
printed
writing that we
slides.
still need practice
We
with.
need to start with
I'm
a
just
formula,
encouraging you that it's a
and then
normal
once we know the
feeling
formula,
that
we're going to apply a
proficiency with
math
that,
question to it.
just
So
takes
again,
time and it takes
even
practice.
though you've kind of
Keep
wrapped up your
practicing the
nomenclature lessons
writing
from chapter
formulas,
2, I really tried to keep
formulas that
integrating
have
the
to be
practices
ingrained and
into
go
the current
quickly.
chapter, just because the repetition
If you've
is our
not yet
friend as
taken
we're
your
learning.
periodic table and placed your
I see
charges in
copper
each and
Roman
every
numeral
box, I highly encourage you to back
That
up and
Roman
find
numeral
that lesson
2 is
with me and get
mandatory
those
in its
in
name
there.
because
It makes formula
copper is
writing
in the heart
very simplistic.
I don't know your
if the
charge
charges
by where
are
you
staring
live.
at you.
It's in the shorties.
For
the
instance,
group
when
B
I find
transition.
sodium in the
Because
box
it has
of
a
sodium
variable
with
charge,
me in a lesson,
I
I wrote
the
the charge
by
using the Roman
any
numeral.
element in this first
So
column.
that Roman numeral tells me the
charge.
When I found
not
chloride,
how many there
Cl,
are. That's a
I wrote
common mistake.
in the box that its
Sometimes
charge
I'm
is minus
confused that
1.
the Roman numeral
That
2
any
tells me
element
to
in
put
that
a
column will
subscript
always
2
be a
there.
minus
That's
1
not
charge.
what it means.
And when a +1 sodium
copper is carrying
bonds
a
to a
+1
-1
That's
chloride,
the meaning of the Roman numeral.
you have a
The
formula
polyatomic
that
ion
comes
called
out
electrically neutral.
Notice the
+1 and a -1
that
is
tells me to
0
check out
overall.
my polyatomic
So no
chart. Just
subscripts
stare
are
it
needed.
down
It's
till you
just
find
simply
it.
NaCl.
You'll become more
based
and more
on
familiar
charge.
with those the longer
If
you stare at
sodium
the
has
chart.
a molar mass,
Phosphate
of
is a polyatomic
23.0,
ion. It's PO4.
Chlorine
and it
has a
carries
molar
-3.
mass of 35.
When you
0.45,
crisscross,
so
we
I'll
read
round that
that
to
as
35.5.
CU3.
I add the two atoms together to get a gram formula mass
taken twice.
And that's how you come out to that formula in the parentheses grams of sodium chloride. Notice how I'm including the label gram. Once we get the formula down, please get in that habit to make sure we keep track of what we're weighing. How many atoms of phosphorus
ammonium
carbonate?
Copper 2 phosphate.
I'm going to bring that down so I can write bigger.
Atoms?
Ammonium is our positive polyatomic ion. It's found on the polyatomic ion chart way to the right-hand side on the down low in that story problem. There's just one positive polyatomic ion called ammonium because we're counting something smaller than the compound we just wrote. We're going to count the individual endings. We're stressing when you hear we're going to count the P's inside that formula. That tells you it's a polyatomic ion. Its number. I have to find carbonate. Its unit on your polyatomic chart, and it's the formula column. Maybe quarter of the way down. I'll set up a series of conversions. Polyatomic side, not periodic table side. 8 tells me polyatomic. It has a formula
brings me to the number of individual
and it carries a minus particles, carbonate.
And that's an Avogadro's number.
One
right?
balance the minus 2 to be electrically neutral. And what I'm counting is this ionic compound. Anytime you crisscross charges are built of ions,
when I
and their building blocks are called
I bring
formula
them
units.
around
the compound
and
is called
down,
the formula
not
unit.
the sign,
positive
we
or
know
negative, but the number.
Because
Avogadro's number
is a quantity,
it's not a charge. Formula unit. When I need to take more than one polyatomic ion, I put it inside a parenthesis. But
I'm not yet
done because we wanted to know individual atoms of CO3. That's the chemical formula for the compound called ammonium carbonate. I'm trying to integrate that last week's lesson to help us kind of keep
answered
based on what I wrote were correct. Ammonium carbonate built of 2 polyatomic ions. I crisscrossed charges. In order to take groups of polyatomics, we have to put it inside a parenthesis and the subscript outside. So now, with the next new part of our lesson, we're trying to calculate how much would I weigh out to get one whole mole of that compound. You kind of trigger, this will need a next step before I'm done. That N 3.5 times Avogadro times 2. So if nitrogen has an atomic mass of 14, there's 2 of them there. That total weight comes out to be 28 grams just from the nitrogen element. Inside the parenthesis is a hydrogen. It has a gram atomic mass of 1.0. I'm just pulling these from the chart. When you look them up so often, you'll just start remembering them. You'll start to just know carbon is 12, hydrogen is 1. And it saves you a little bit of time once the repetition occurs.
Yay.
How many hydrogens are in that compound?
I think I'm proud of myself. I hit that one right.
There's 4 taken twice, 4 times 2
today we practiced
mole map skills.
We
integrated nomenclature. I'm going to continue to do so best I can. When we come back Thursday, we're going to talk about empirical and molecular formulas and there's a unit known as molarity. Continue bringing your calculator. Consider bringing out those test-taking tool pages so you can make sure they're test-ready by next formula mass or a general
we're off
to lab where we'll practice nomenclature. So on my calculator, I'll add 28 plus 8. If you have questions, please stick around. I can answer them as needed. A total of 96 grams of ammonium carbonate. We are building, kind of looking at the mole map where this is heading.
I don't have one to print out. If you find a good image, you may certainly print one.
I know that there's one unit called the mole. How much do I weigh out?
The Google
known as its molar mass. Yeah, that staircase.
And the third one I asked you to
like
do
that,
is
but you can probably find that as an image already built. This is a binary compound built of 2 ions, potassium. Potassium is found in the first family on your periodic table. In the box of potassium, I asked you to write its charge. Any element in that first column is always a +1 charge. Oxide comes from the element oxygen. I'm hearing "ide" because it's an ion. The negative ion ends in "ide." Oxygen, inside the box, I asked you to write its charge. Any nonmetal in group 6A will carry the -2 charge. We wrote that. It has to gain 2 to have 8. So if K is a +1, O is a -2, and I just like to write the charges up high. It's not part of the formula, but it's just a tool that helps me figure out the formula so that when I crisscross, I can bring those around and down and know the subscripts for that compound. Potassium oxide has a formula of K2O, 2 potassiums and 1 oxygen. Potassium has a formula weight of 39.0983. If we agree to carry 1 decimal, I'll call that 39.1. But there's 2 of them there. Oxygen weighs 16, so I'm going to sum 2 Ks and 1 O. And did you find 94.2? Excellent. So we went through atoms, molecules, and then formula units. So far you should have, 9 little mass numbers on your paper so far. So that term, molar mass, that's the exchange unit that we'll use that brings us from the weighing into the center of our mole map known as the chemical mole. The exchange unit called molar mass, the mass of any compound, the mass of anything that I want 1 mole of, is referred to as the molar mass. And I just reminded myself to remind you to be careful about the 7 naturally occurring elements. It may be vague. If you hear what's the molar mass of hydrogen or chlorine, bromine, iodine, any of those 7 elements, this is a vague term. I would need to know specifically, do you mean an atom or do you need a molecule? So with those 7 elements, we just want to be careful to be very precise in the language. Otherwise, the general term molar mass works fine. What's the molar mass of? And then you just add the weights off the periodic table. Without calculating, not a numerical answer, this is a conversation. Could you check in with a neighbor to make sure you have the same understanding of the process? Describe with your neighbor, how would you find the molar mass of ibuprofen? Ibuprofen has the chemical formula I wrote bigger up on the screen so you can see it. Without solving, discuss the process of what you would do. Please talk. I cut you off. I hooked ammonium to carbonate.
Now, where do we get
this side? I can't even read that. Maybe you can. Well, give yourself some time, bring it back. We're just looking up these weights and adding them together. It's just addition. You're trying to do next steps, I think, yet we're not yet there because you have a bigger picture of what we've been doing. Yeah, we're not there yet. We haven't moved yet. We've just tried to figure out conversion factors. Yeah, perfect. I like the lecture pause just to check in and make sure what I'm saying is clicking. And what really cements the learning is making you say it in a different way. Saying it to a neighbor actually solidifies your own learning. So thank you for engaging. And what you're discussing is the process, really, and just kind of sharing how you found the weight of each of the elements from the periodic table. These numbers are what we found off the box of each element. And then you took the subscript to determine how many there were. You're multiplying each individual element's contribution to the total to sum to find the entire mass. So the process is what we did, no need to solve there. What I'm gathering is that it's the formula writing that might stumble, but I get the idea of adding so far. So we'll continue practicing as best I can, sprinkling in nomenclature practice. How about, I'm going to cover that up for a moment. If someone asked you to find the molar mass of aluminum sulfate, work with your neighbor to discuss what the formula is for aluminum sulfate. Can we get that far through a discussion? Aluminum sulfate. Time to go. Okay. Excellent. So I like what you're doing because you're helping yourself count how many there are. Comfortable? Good. So my front vantage point, it's all about the conversation and reminding each other, okay, how do I know the charges? Where do I find this? Where do I find that? And that truly deepens your learning. So compliments to the engagement and conversation. As simplistic as that question might be, there is a lot of talk going on, and that talk is very helpful in remembering nomenclature. So when I wrote aluminum sulfate, you said, okay, aluminum is this element, it has a symbol Al. I found that from the periodic table. And in the box of aluminum, I wrote myself its charge. You're doing yourself a favor if you go back and make sure your charges are written in the periodic table, on the periodic table that you'll be using on the test, right? Not some random other one, but the test-taking tool page. I can see aluminum is a metal in group 3A. It will lose 3 electrons. It's a +3 charge. From the polyatomic page, and I know it's polyatomic because I'm hearing 8, right? 8 and ite, those endings tell me that it's some kind of oxygen, polyatomic. Sulfate is SO4, and it carries a -2 charge. A +3 and a -2 do not balance, electrically balance to 0, so I know I need to crisscross. The crisscross tells me to come around and down to place as a subscript. Subscripts don't have charges on them. It's a quantity, so don't grab the negative with it. Just bring the 2 around and down. And that this 3 tells me I'm going to need 3 groups of the sulfate ion. So if I group polyatomics, I have to place them in a parenthesis. And I read that as saying Al2, SO4 taken 3 times. That's how we read that formula. Aluminum, there are 2 of them in that formula. And when I find the molar mass of aluminum, I would call it 27, 27.0, carrying the 1 decimal. When I find sulfur on the periodic table, it rounds to be 32.1. How many sulfurs are